Hi, I'm Carl Franklin. In this episode of Blazor Train, I'll show you how to draw graphics with the HTML5 canvas element and even do complex animations, all using C# and no JavaScript. Oh, there's JavaScript under the hood for sure, but you won't have to touch it. See, I found a couple resources online you can use, and I even wrote a helper component to fill in the missing pieces, so you can stay comfortably in the world of C# and build complex animations in Blazor Server and Blazor WebAssembly apps. So stick around, because drawing on the canvas in Blazor is coming up right now, right here on Blazor Train. So the code repo for today is Blazor Canvas at my GitHub account, github.com/carlfranklin/blazorcanvas. And I'm making use of this Blazor extensions/canvas, a wrapper around the HTML5 canvas APIs. It supports both 2D and WebGL, Blazor Server and Blazor WebAssembly. But here's one thing I want to point out. As of this recording, the last update was April 22, 2021, and the last release was February 17th. So the release is not up to date with the code. Now, you can download the code and install NPM and Node and NVM and all that stuff and get it working, and maybe you can compile it. But I really want these guys to get off their duff and release the current version as a NuGet package. But it's really okay. We can work around it. Now, I don't claim to be an expert on the canvas, but I do have in my repo a link to an HTML canvas tutorial at w3schools.com that's pretty good at getting you started with text and graphics and animations and all that stuff. Simply put, the canvas is built into the browser in HTML5, and it's a drawing surface, much like a graphical canvas in a WPF app or something similar on other platforms. You can essentially draw text, you can draw images, you can draw graphics, you can do complex shapes and arcs and all of that stuff. It is for graphical drawing. Now, there's a really cool place online that I want to show you called 25 Ridiculously Impressive HTML5 Canvas Experiments. So these are all JavaScript, right? And they show you the HTML, the CSS, and the JavaScript, and they give you a live demo, and it's really cool. There's a lot of cool demos here just to show you what you can do. This is a really good one. Now, I'm not saying that you can just whip this stuff off, basically convert the JavaScript to C#. It's not really that easy, but I'm going to get you started at least. If you know how to use the canvas object, I'm going to make your life a lot easier. So getting back to this Blazor extensions, it's very simple. We have a NuGet package. So let's just go ahead and create a new Blazor server application and follow the instructions here in the Blazor extensions canvas repo just to see what happens. All right, so my application is called Blazor Canvas, and the first thing I'm going to do is install that package. So Blazor Extensions Canvas. And the way I'm going to do that is just to go to the CS proj file and include the package. So the next thing I need to do is copy this script link and include that in the _layout CS_HTML file. And I'm going to put that right down here. All right, well, we have to add this using statement to imports Razor. And now we can instantiate a BE canvas, and let's use index for that. Now, of course, there's a Canvas reference here, so we're going to need some code, and we'll go back to the page. Here is the code. Now we need more imports statements. So I'm going to go to Blazor extensions, Canvas 2D. Let's see if that worked. And this right here is in extensions. Now it looks like it's going to work. Okay, so what this code is going to do on after render async, it's going to get the Canvas context from the reference create Canvas 2D async. Then we use that context to do operations on the canvas. So we're setting the fill style to green. We're filling a rectangle with these coordinates. We're setting a font. And we're drawing some text, hello Blazor. And let's see what happens. Ooh, isn't that amazing? No, it really isn't. I'm not stopping here because it's all well and fine to just draw some stuff on the screen, but the real power of Canvas is in the animations. Remember those animations that I showed you, those 25 amazing examples or experiments about Canvas? Those are animations. So I immediately wanted to know, well, how do I do that? And how can I interact with Blazor so that I don't have to do any JavaScript? Well, step one came in the form of this blog post from Scott Harden. Draw animated graphics in the browser with Blazor WebAssembly. Now, first of all, it doesn't have to be Blazor WebAssembly, but that's what he's using. And here's a live demo. There you go. So he's doing an animation. This is not just one drawing. You can even see up in the corner here, he's got the frames per second updating. As you can see, it's a little rough, but the frame rate is all dependent on your machine. So let me pull up his code and you can see what he's doing. All right, here's his app in Visual Studio. Let's run it. So this is running locally. Let's take a look at what he's doing. This is a WebAssembly application, so all the JavaScript is in index HTML. He really doesn't have a lot of script. He's got this that he calls from Blazor, window.initRenderJS, and he passes his .NET reference in. And I like this. He's using this technique, just saying window.theInstance equals instance. He's using the window as a place to save the state, which is cool. So then he's calling window add event listener resize. So anytime that the browser gets resized, he wants it to call resize canvas to fit window. And then he's calling resize canvas to fit window immediately. And then he's doing this other thing called window.requestAnimationFrame. Now, if you look at the documentation for window.requestAnimationFrame, here's what it says. This method tells the browser that you wish to perform an animation and requests that the browser calls a specified function to update an animation before the next repaint. The method takes a callback as an argument to be invoked. So you might think that, oh, I'm doing an animation. I'm going to use a timer or I'm going to use a tight loop. Well, that's kind of piggy, isn't it? You're kind of forcing your will on the whole system. And as we know, a modern system is in balance. And the browser especially has specific time slices that it dedicates to rendering. And so this is more efficient to say, hey, browser, you call me and tell me when it's time to render a frame of an animation or draw on the canvas one frame. And that way, everything just becomes more efficient. You're not forcing a frame rate, right? As you saw in my VM, I get 30 frames per second. On my desktop, I get 120 frames per second. So you're letting the system dictate when you can draw a frame. This is good. So getting back here, after the initialization happens, the code calls window.requestAnimationFrame, passing the callback render.js. So this is render.js. The instance, remember that's on window, .invoke method async render in Blazor. Yep, That is a C# method in the Blazor app with a JS invocable attribute so that we can call it back. And then once it's done, it calls, hey, request animation frame again. Render JS. In other words, call me again when it's time. Now here's that resize canvas to fit window thing, because this happens on resize. Remember, right down here, add event listener resize. So we're looking for an element called canvas holder. That's the ID. And if we get that, then we're going to select inside of that canvas. And if we get the canvas, we're setting the width and height according to the window size. And then we're invoking resize in Blazor with the width and height of the canvas so that our C# code knows that the window has been resized. So this is all good. Let's take a look at the page itself. So here you can see our div with the ID canvas holder, and it's got, a little style to it. Position fixed, width, height 100%. And inside that is our canvas. Now we have a canvas reference, and on after render, we're calling await canvas reference create canvas 2D async. Good. And then we're invoking the JavaScript init render.js, passing ourself as an object. And here are our two JS invocables. The first one is resize in Blazor, passing the width and height, and he's calling a resize on our object. Then we have the render in Blazor JS invocable, which is where he's rendering the frame. He's also calculating the frames per second based on the last render time, and then he's doing all the canvas code to draw the next frame. So I thought this was really cool, but my job this week is to remove all JavaScript for you so that you don't have to do any JavaScript. So I came up with a wrapper around all that JavaScript that makes it easy for you. And it's called AvnCanvasHelper. And it's a Razor class library in my repo. And at some point, I'll probably move this into its own NuGet package to make it easier. But, like everything else, I want to just take it slow and we'll see what happens. So AvnCanvasHelper is a wrapper that you use around the canvas. You see? So I have a canvas resized event that you can handle. You don't have to do a JS invocable. You don't have to call JavaScript. It's just a Blazor component. I have a render frame event that happens when you need to render another frame. And just for the heck of it, I put in mouse events, mouse down, mouse up, mouse move, because sometimes you want to interact with an animation. I know, hard to believe. And then you have the canvas inside of that, and that becomes a render fragment in the canvas helper. So what I did was I wrote this demo using the Blazor canvas and my AvnCanvasHelper with the rendering code from Scott's demo. I'm going to download my code just as a zip file so I can get that AvnCanvasHelper out of it. I am going to copy this folder into my solution folder. So I'm going to open the solution folder in File Explorer, and I'm just going to copy this guy into here. Now I can add an existing project, AvnCanvasHelper, right there. So next thing let's do is right click on Blazor Canvas and add a project reference to AvnCanvasHelper. Now I'm going to add just a couple more using statements to underscore imports. I've got AvnCanvasHelper and also system drawing. And I've also added the WebGL namespace just in case you want to mess around with that. Now I don't want this layout. I want to delete all this and just have the body by itself. I don't want any of the gobbledygook of the template. Now the next thing in Blazor Canvas is I'm going to add a new folder called Models, and we're going to add two classes in here. The first one's called Ball, and I've given Scott Harden complete credit for all of this because it's really his code. I'm just using it within my framework here. So this defines a ball in Scott's demo. And the next one is called field. Finally, I'm going to take over index and I will explain it all. So let's dig into Canvas Helper. Canvas Helper, the markup is remarkably simple. I have a div around my child content, which is just a render fragment. And this div is called Canvas Holder. The position is fixed, the width and height are 100%. So it's going to take up 100% of the field that it's in. And there's my child content right there. You've seen this pattern before. I know you have, because I've showed you. Okay, let's dive into the C# code. So this is my code behind. I'm using the lazy task of IJS object reference. This technique is outlined in the template whenever you create a Razor class library. There's an example interop.js library. It's no different. I'm just doing it within a component. So here's my module task. And I have an initialize method that the user needs to call from onAfterRender when first render is true. Right, so we can't do this until JavaScript is all in place, the JavaScript engine and everything's working, and we can actually make a call to it. So this is the path to my JavaScript file. It's always going to be that path from within this component because it is right here. Here's my JavaScript file. Again, giving Scott complete kudos and credit for this. So the only function that I'm exporting, meaning able to call from code, is this init render. So I'm doing exactly what he did with the resize and resize canvas to fit window, but I'm also handling mouse events. So my render.js is the same as his. My resize is also the same, but I also have these events for handling mouse down, mouse up, and mouse move. And you notice I'm also passing these arguments. Look at this. Here's a canvas mouse move args function that returns an object with the following properties. Now, E is the event argument that is passed in on mouse down, mouse up, mouse move. I'm passing that on to my canvas mouse move args. So check this out. I've actually created a C# class that has all of these properties, and they are all on this particular thing right here, this mouse event. And you can read more about it at this website right here. This is the mouse event, and it tells you all of the different properties. And if you want to implement more properties like layers, meta keys, other things that I haven't done, page X, page Y, related target, you can just add them in there. So that's my JavaScript. Getting back to the code, after initialize, we have to, once we create the module task, we have to await the value to get the module. And then on the module, we call invoke void async init render.js. And then we dispose the module. That doesn't get rid of the JavaScript, it just disposes the .NET object. I know it's really weird when you're doing JavaScript interop in Blazor. You have a Blazor object that refers to it, and you also have JavaScript objects. So two different things that need to be dealt with memory-wise. So here's our JS invocable resize in Blazor, and I'm calling my event canvas resized. Right, here's my parameter. Canvas resized. Here's my event callback for render frame. And then mouse down, mouse up, and mouse move. They all take canvas mouse args. Here's my render frame. This timestamp right here is not used. I'm doing my own calculations here. But here's the cool thing. All I'm doing is passing this on with an event callback. So the real code, the real logic is done in the Blazor application. So let's go back there. So I'm saying my canvas resized event is canvas resized. There it is. My mouse events are blank. I don't have anything in them. You can use them if you want. And then my render frame method right here is what gets called whenever we need to render a new frame. So we're updating frames per second, which is passed in. And all this code is exactly the same as Scott did in his demo. I'm just doing it without JavaScript. Well, without having to do any JavaScript. So on after render async, if it's the first render, we're getting the context, creating the canvas, calling initialize, and the rest of it is just handling the events. Let's run it. So there you go. I really hope you've enjoyed this presentation and you're inspired to go dig into the canvas and do some animations. Heck, maybe you'll even implement some of those crazy graphics things that I showed you earlier. Whatever it is, have fun with it and keep in touch. Now back to you in the studio, Carl. As I said, I'm not an expert at converting JavaScript to C#, and I'm certainly no expert on using the canvas, but I feel there might be a few Blazor trained passengers who know how to program the canvas and are ready to jump off the JavaScript train and onto the Blazor train. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blazor train.